Okay guys, in this video we're going to talk about how do we take measured values and then use them in a mathematical calculation and then round off those final answers from those mathematical calculations. Okay, so first thing we want to do is we want to talk about multiplication and division, because there's actually two sets of rules depending on what kind of calculation you are doing. So if you are multiplying or dividing, here's the rules we're going to deal with, and then we'll deal with adding and subtracting next. So in multiplication and division, for each measured number in your calculation, okay, so anything that's measured, determine how many measured numbers you have, otherwise we call those significant figures. Okay, so how many sig figs or how many significant figures are there? Basically, you're counting them. Okay, so we go down here. So first step is, in this measured number, how many layers of precision do we have, or basically how many measured numbers, or how many significant figures do we have? Well, we have a 6, a 5, and a 5, so there are 3 of them. Here, that 0 is a placeholder, so we'll ignore it. And we have the 9, the 9, the 4, and the 3, so we have 4 of them. Over here, we have the 5 and the 2, so we have 2 of them. So we are looking at 2 layers of precision, or 2 sig figs for this measurement. Okay? Once you've identified the number of significant figures for each measured number, then you just take your answer and you round it to the same amount of measured numbers, or sig figs, as whichever one is smallest, or the one that's the least. Okay? So here's an example for us to take a look at. So here's a kind of classic density problem where we have 16 grams, dividing it by 37.7 milliliters. If we do the math, our dumb calculator gives us this 0.424403183 grams per milliliter. It doesn't even label it for us. We got to do that ourselves. So it gives us a long, drawn-out answer, which does not have really any representation of the precision of our measurements. If we go back and look, this number, the 16, only has 2 layers of precision, so it has 2 sig figs. This number has 3 in it. So as a result, if this one has 2, this one has 3, we round our answer to 2. Again, ignoring that first 0 out front as a placeholder. Make sure we label it, and we're done. Now, when you're working with calculated values coming from measurements, one thing you want to be aware of is you make sure that you do not factor in standards, constants, counted values, conversion factors, or anything else that's not measured. Okay? So if someone hands you, $5.32, that's not really measured. That's money that you count. So you wouldn't round things based off of that number. Standardized numbers that come from a table, constants like pi, conversion factors like 1,000 grams equaling 1 kilogram. Those numbers seem measured, but they're really not measured. They're really just a mathematical equality. So anything that's not measured that might be part of the math, you ignore. Only the measured values from the math play a role in determining your rounded values. Okay, so that's the first one. For additional practice on multiplication and division, there's a worksheet that you guys can do. It's called worksheet number 1 from the unit. It gives you 5 more additional problems with an answer key to check your work, to check your understanding. So go ahead and do that to double check what you understand with this. Now, if we're adding and subtracting, so we're switching over to adding and subtracting now, when that happens, you take your measured number from the calculation. Now you want to determine at what level the precision ends. So we are not counting significant figures here. Okay, I'm going to say that again. We are not counting significant figures here. Okay, you're going to find the place relative to the decimal. The measurement stops. So here we're looking for a location, not a number. So in this measurement, the measurement ends in the hundredths column. In this measurement, the measurement ends in the ones column. In this measurement, the measurement ends in the tenths column. So where the measurement ends, that's where our precision ends. So for adding and subtracting, you want to round your answer to the same precision, that place relative to the decimal, of the least precise measurement. Okay? So we have 3 things being added here in our example. We have 35.7 grams minus 22 grams plus 3.4576 grams. If we, that should be a plus sign in here, sorry. If you add these all up, you get 61.1576 grams, okay? However, looking at our precision, this measurement ended in the tenths place, this measurement ended in the ones place, and this one ended in the 10,000ths place, okay? So because this last digit is always an estimate, it's not a guaranteed value, this is where we get to round it. So this one, this 7 might be a little bit off. Here, the 2 might be a little off. So it really doesn't matter if we're adding or subtracting all these things down here, because they're way more precise than this measurement here can give us. So this 22, we're just going to say, well, it's the ones column, tenths, once, and 10,000ths. The ones column is the least precise, so our answer has to be rounded off to the ones column also. Okay? It has nothing to do with the fact that this happens to have two sig figs in it. That just is completely a coincidence. It is only rounded because of the location that this measurement ended. Okay? Again, for standard numbers, constants, counted numbers, conversion factors, and so forth, anything else that's not measured, you would not factor that into your rounding for these. Okay, guys, those are your two straightforward rounding rules in terms of how we round things when it comes to numbers. We will apply these rules from here on out the rest of the year, and actually you're going to apply them in physics next year, and you'll apply them as you kind of move into any collegiate science classes also. So make sure you're comfortable with these, because that way you no longer have to ask me where do I round this number. You will always have a set of rules to follow to do that. Again, if you want some additional practice, there's some worksheet number 2, has 5 additional practice problems on that works you through adding and subtracting. It gives you some different scenarios you can work under, and also provides a key for you. Thank you.